Let's consider transformation of absolute functions. Okay, I've taken a very typical example. It's not that simple, but I hope you have seen the video for horizontal transformations and the other video on transformation details before this, so that this becomes easier for you to understand. Okay, let's consider the function f of x equals to 5 minus absolute of 2x plus 4. Now, we are comparing it as a transformation from our original function fx equals to absolute x. Now, this is a transformed function. What is the transformation? If you see it, it's better to reorganize these values so that the things become much more clear to us. Always, if you get a mixed up function like this, write it in the most familiar form. Okay? Familiar form for me will be, I'll bring this first. 2x plus 4, and this is plus 5. Now, inside, the coefficient of x should always be 1. If not, you have to factor that out, okay? Then we say absolute of, let me take this 2 common, and when you do so, you get x plus 2 plus 5. Now, this sounds familiar, right? Let's see each part. What do they reflect? This minus 1. What does this tell you? It is a reflection on what? It's a vertical thing. It's outside the brackets, so it's vertical. So it reflects like this on x-axis. How about this 5? It is a vertical translation outside the bracket. So say vertical translation five units up. Now let's get into the inside of the function. Here, what does this 2 represents? This 2 is horizontal stretch or compression. In inside, things become reversed. If it's more than 1, it's compression. So we say horizontal compression by factor of how much? 1 over k. Do you remember? Factor of half, 1 over 2. So this is the effect of this 2. And how about this 2? This 2 is horizontal translation 2 units to which side? Left. So that is the transformation which we are looking for. Okay. If you don't really factor these things, then you may get a wrong result. You may think that you are moving 4 units left, which many students do, right? That's a big mistake. They may get other things right, but this may be wrong. Second, if you don't really organize these things like that, it is not that clear that this is reflection on x-axis. It's kind of a confused state of mind. So it creates a bit of problem, okay? Now, we will attempt to do this in 2 different ways. One, I would like to show you how the coordinates transform, okay? On an absolute function, the basic coordinates we saw were 0, 0. So let me write those coordinates. 0, 0 is the origin, right? And we can take minus 1 and plus 1, plus 1, 1, 2, 2, and even minus 2, 2. So these 5 coordinates give us a function, absolute function graph to the perfection, right? So you have origin and 1 point here, 1 point here, origin, 1 point here, 1 point here, extended. That should work, correct? Now these are our points to consider. Now in general, if I have x, y as a coordinate on function fx, let us say these are my points on function fx, right? Then how are these points going to get transformed on this function? The transform function. Okay, what is happening to the x points? X points are getting multiplied by a factor of half, and then you do 2 units to left, that means minus 2. So our transformed x point is half of this value of x minus 2, correct? So that's the x value. How about the y value? Y value gets reflected, so it becomes negative times plus 1. So it is negative of y plus 5 units up plus 5. So that is the way each point is going to get transformed. Okay, so we'll apply this, and once we apply this, we get our final points after transformation. Okay, let's do that. So let's apply this to 0 first. 0 times x is 0 minus 2. So this point origin, the vertex, moves to minus 2 in x position, and the y point, 0 times minus is 0 plus 5. So that is what happening to our origin. Now let's put 2. I will prefer not to put 2 for the time being. Let me use even number 2, 2, right? Because then we avoid fractions, correct? I know these are our critical points, but depending on function, we should choose points which are good for us, correct? Good for us is 2, 2, right? So let me take 2, 2 this time. We have options. X belongs to all real numbers. You could take any point, right? For drawing a line, how many points do you need? Just 2 points, correct? Yes, so we will do that. So if you plug in x as 2, 2 divided by 2 is 1, and 1 minus 2 is minus 1. And here, if you put this 2 for y, you get minus 2 plus 5, which gives you plus 3. So this 2 gets transformed to minus 1 and 3. Now we will use this 2, okay? So if I put minus 2 here, we are not considering this point, okay? When I put minus 2 here, minus 2 divided by 2 is minus 1, and you get minus 3. How about 2? When you plug in 2, minus 2 plus 5 is 3. Correct. So these are our transform points. Now, so if we join these points, we get the transform function. Now let's look at the graph. Here it is. I've already drawn absolute x graph for you, but let me write the function once again for you, okay? The function which we are trying to now graph is f equals to, I will write our modified function, or this is a simplified function, not modified really, but simplified. 2 times x plus 2 plus 5. This is what we want from here. Okay, now let's go through the transformation and do it in steps. First step, reflect it on the y-axis. If I do the reflection, this is what I get, right? I'm drawing it light. I don't really want to mess it up. So let me do this reflection. This is a reflection. So we have taken care of minus 2. I hope it's clear now. So taken care of minus 2. Now we'll take care of this function. Well, let me tell you one thing. There are 2 ways to do it. We could do inside out. That means we could do this first and that. Or we can start from left to right. I prefer going from left to right, because if you do left to right, you'll always do multiplications first and then translations. You're not going to make a mistake. So left to right is a very good option. This is multiplication, and these two are subtractions or additions. So these are translations, horizontal, up or down, or vertical up and down, whatever, translations. So I prefer to go left to right. So when you go left to right, minus reflection, that's the first thing. Horizontally compressed by a factor of half. It means what? It means that this, let's consider this point. So this point is how many units? 1, 2, 3. So it will come to center, 1.5. Correct? 1, 2, 3. It will come here. Better point for me was this. You understand? 4. Because half of 4 is 2. And I know 1.5 is kind of dicey. How about 0? 0 remains there because half of 0 is 0. So we can now join our line like this. So let me write, this is minus of fx. Is that okay? Because we just reflected our fx. I'm writing this fx in blue, the original function. I should have used gx or something else to avoid confusion. But now, well, we are there, halfway through this. And then here, what did we do? This is, we already have the minus, the reflection, and we have already done horizontal compression by a factor of 2. So it is minus f of 2x. So we are till this place. What we are left with? Translation. And this translation is 2 units to left and 5 units up. Let's do that in red. So here, this vertex, 2 units left and 5 units up. 1, 2, 3, 4, 5. There you are, right? This is 1, 2, 3, 4, 5. This is our 5, correct? Yeah. So 2 units left, 5 up. Now let's take any other point. This point you want to take? Let's take it. Oh, the line is the blue line. So we'll go 2 units left, 1, 2, and 5 units up. 1, 2, 3, 4, 5. There we go. This point, 2 units left, 1, 2, 5 units up. 1, 2, 3, 4, 5. There you are. So once we have these points, we can join them. Before joining, let's check with our original points, which we got from transformation. Do you remember which points I'm talking about? Let me bring it down to you. These set of transform points. Do you see that? Those are the points. Okay, let's check them. Minus 3 and 3. So go 1, 2, 3, 1, 2, 3. I think it falls. That seems to be okay. Vertex is the best point to check. Minus 2 and 5. Minus 2 and 5. It works. Is that okay? Minus 1 and 3. So minus 1 and 3. 1, 2, 3. So these are our points which we got from that equation. And they seem to fall in our line. So we are perfectly fine. So let's join them. Here we are. So this becomes our transform function, fx. Do you see that? So in this video, you saw how to transform an absolute function. First step was, let's get back to it. Whenever you get a function, write it in a familiar form. Now, what is that familiar form for you? For transform function? Let me write here, familiar form for transform function is, you normally write like this, a f of k x minus t plus c. Do you see this part? K and within bracket x minus t. And what is the coefficient of x? Nothing. 1, 1, 1. And whatever, if we write something like we gave here, you have to factor this out. It becomes a part of k. Do you see that now? Perfect. So first thing, as I showed you, was given a function, write it in your familiar form. Okay. So we just interchange and factor out 2. Most important. People forget about this. Then you could take this path or the second path. Both are good enough. Okay. Unless and until it is specified that show your transformation in steps, then you have to take this. Sometimes you are required to find the image points from the given points. Then this is very good, right? Now these are called the image points, correct, of the original function. How do they get transformed? Here the x values, the inside values, we multiply them by half and then move 2 units to left. For the y values, we reflect them on x-axis and move 5 units up. So on each original point, you apply this transformation to get your image points, plot these image points and draw your curve. You're done. The second approach is start with the original function. This is my absolute x. Now here I reflected. Do you see that? I reflected this because of minus right in the very beginning. What is our a? A is minus 1. So I just reflect it. and this got reflected by this curve. Do you see that? And second step, horizontally compressed by a factor of half. Bring them together, closer and closer, half distance. Okay? So, for example, this point is at 1, it brought to half. Do you see? This is at 2, brought to 1. Do you see that? Bring it closer, half the distance. That's where. And then we got this blue line, which is minus of f of 2x. Minus reflection on x-axis, 2, horizontally compressed by a factor of half. And then we did both the translations together. Left 2 units and 5 units up. So we moved this point 2 left and 5 up. Got the vertex of the new one, and you can take any other point and move 1, 2 and 1, 2, 3, 4, 5. There you are. So you get a graph. Okay? I think now it's absolutely clear to you how to transform absolute function, or for that matter any function. Okay? Thank you.